Welcome. You have just tuned into Science for Sleepy, the place where we take the most puzzling questions in science and unwrap them slowly, layer by layer, until they feel strangely simple. Tonight, you and I are going to wander through a question that has unsettled philosophers, scientists, and even billionaires. What if the universe, your life, and every single detail you take for granted is nothing more than a simulation? It sounds dramatic at first, like something pulled out of a late-night science fiction movie, but here's the strange part. Many highly respected thinkers believe that this idea might not only be possible, but actually very likely. Some even go as far as to say that the odds of you living in a base reality, a real and original universe, are surprisingly small. Let that sink in. The computer you are using to watch this video might itself be part of a computer program, nested inside another computer, nested inside another like Russian dolls that never quite stop. Before we dive further, let me ask you something. Could you do me a small favor? Scroll down for a second into the comments section and let us know where you're watching this from and what time it is there. It's always fascinating to see how many different corners of the world gather here at the same time to think about these mind-bending ideas. And while you're down there, if you haven't already, gently tap the subscribe button. Think of it like this. If the universe is a simulation, maybe hitting subscribe is the one action that tells the hidden programmers that you're paying attention. And don't worry, it won't break the simulation, at least we think so. We post a new video every single day, so consider this your daily checkpoint inside this strange digital experiment we call life. So, where do we even begin when we talk about simulated universes? Perhaps the best way is to start with the unsettling fact that everything you experience right now, your sense of touch, the sound of my voice, even the colors you see, is not the real world itself. It's an interpretation your brain constructs out of electrical signals. Your eyes don't see light directly. They detect vibrations of energy that your brain translates into the illusion of color. Your ears don't hear sound itself. They register pressure waves in the air and convert them into the experience of voices, music, or noise. Already, you are living inside a kind of simulation, one generated by your own nervous system. You never interact with reality as it truly is. You only deal with its processed version. If that feels like a small detail, remember that small details often hide the most important truths. This idea stretches further when you think about the progress we've made with technology. Go back only a few decades, say. The early 1980s and video games were made of simple blocks and beeps. Fast forward to today, and we have virtual reality so convincing that people have trouble distinguishing between a game and the physical world when their senses are fully immersed. Add in artificial intelligence capable of generating human-like conversations, digital landscapes that mimic entire cities, and you realize something important. If our technology has advanced this far in such a short time, what would a civilization millions of years older than ours be able to create? If we can simulate weather patterns, global economies, and the physics of particles, why couldn't they simulate entire universes, including you? There's also a philosophical angle here. The Swedish philosopher Nick Bostrom famously argued that one of three things must be true. First, civilizations like ours will go extinct before they reach the ability to create universe-scale simulations. Second, advanced civilizations might develop the technology, but have no interest in running such simulations. Or third, if neither of the first two are correct, then the number of simulated realities would far outnumber any base reality. And if that's the case, the odds suggest that you are almost certainly living in one of those simulations rather than the original. It's not a thought experiment designed to shock, it's a mathematical conclusion, boring and logical, like the way you might calculate the odds of drawing a certain card from a shuffled deck. But maybe the strangest part is how ordinary life feels in the face of this possibility. You might have brushed your teeth this morning, walked the same route to work, sat through a meeting, made dinner. Nothing about those small mundane moments hinted at a simulated framework behind it all. And yet, if you look closely at the structure of reality, down to particles that appear and vanish in quantum fields, you notice peculiar glitches. Physics doesn't always behave smoothly. At the tiniest scales, things don't move in continuous flows. They jump in packets, in discrete steps, almost like pixels on a screen. The universe, it seems, has a resolution limit. That may not prove anything, but it feels suspiciously like the kind of thing you'd expect if everything was being computed. Still, even as you're lying there now, perhaps drifting towards sleep, ask yourself this. If everything you know, including your own sense of self, was being generated inside some vast machine, would you even want to know? Or is it enough to live inside the illusion, content that your days, your thoughts, and your experiences feel real whether or not they are? If you really sit with the idea that the universe might be a simulation, one of the first questions that naturally comes to mind is, how could we ever tell? After all, if the simulation is perfect, then every test you could think of might already be accounted for within its code. But history shows us something interesting. Even in our own creations, no matter how advanced, glitches appear. A video game with perfect physics still has occasional bugs. A program designed to mimic human thought eventually makes strange errors. And when we look closely at our own reality, we can spot hints that suggest imperfections, patterns that don't quite line up, or laws that appear almost too neatly written. Think about mathematics for a moment. Why does the universe seem to follow strict mathematical rules? Whether you're tracking the orbit of a planet or the fall of a pebble, equations describe it with eerie precision. Some would say this is just the beauty of nature, but others argue it feels too much like programming. The laws of physics are not endlessly creative. They are efficient, predictable, and strangely elegant, almost as if they were coded into the system. That detail may sound boring at first, but it is also deeply telling. Efficiency is the mark of design. If someone, or something, wanted to generate a universe, they would need a framework rules to keep everything consistent. And what better framework than mathematics? Now, here's another curious angle. Our search for the smallest pieces of reality. When scientists built particle accelerators to smash atoms apart, they expected that smaller and smaller particles would appear infinitely divisible, like layers of an onion. Instead, they discovered something surprising. At a certain point, the universe does not break down into infinitely smaller pieces. It stops at a level where particles act like indivisible building blocks. This is similar to how pixels on your screen cannot be divided beyond a certain resolution. Zoom in as far as you like, and eventually you reach the smallest unit. Doesn't that sound oddly familiar? And then there's quantum mechanics, perhaps the most unsettling part of modern physics. Electrons, photons, and other tiny particles don't behave like tiny balls of matter. They exist in blurry clouds of probability until you measure them, and then they suddenly snap into a definite state. To many, this seems like the universe waiting until you look before it bothers to render the details, like a video game conserving computing power by only showing what's on your screen. If the world truly operates this way, it hints at a strange economy of reality, as though resources are being saved for the parts you interact with. Yet, despite these strange hints, daily life continues without interruption. You make breakfast, drive to work, answer emails. None of those experiences ever betray the presence of a hidden machine. This is where the idea becomes most unsettling. If we are inside a simulation, then the programmers designed it to be seamless, to lull us into the feeling of normalcy. And if that's the case, then every dull detail of your life, the hum of the refrigerator, the way your socks feel slightly too tight, the pattern of cracks on the sidewalk, those are not mistakes. They are the meticulous filler of a world built to keep you immersed. Of course, you might ask, who would build such a simulation, and why? That question opens an even stranger path. Some suggest that advanced civilizations might simulate universes as experiments to study their own origins. Others imagine simulations as entertainment, vast playgrounds where consciousness is set free to explore. There's even the possibility that you are part of an ancestor simulation, created by future humans to look back on their past. In that sense, your struggles, your achievements, your very identity could be nothing more than data running in a vast archive of possibilities. If this all sounds unsettling, remember this. The possibility doesn't change how your morning coffee tastes or how a loved one's voice feels when they laugh. The emotional texture of your life remains intact, whether real or simulated. The simulation argument doesn't erase your experiences, it reframes them. And maybe that's the most profound detail of all, that meaning doesn't vanish when reality is questioned. If you feel joy, then joy is real, regardless of its source. Still, one can't help but wonder, if the universe truly is a simulation, would the programmers ever reveal themselves? Or are we destined to live out our entire lives never knowing, our questions echoing unanswered within the walls of this vast hidden machine? One of the most intriguing aspects of this idea is how it has quietly threaded itself through history long before computers existed. Ancient philosophers wrestled with questions that sound suspiciously like early versions of the simulation argument. In the dialogues of Plato, there is the story of the cave, where people live chained, facing a wall, mistaking shadows for the full reality. They believe the shadows are all there is, never realizing that what they see is just a projection of something richer and more complex behind them. Replace the fire in that cave with advanced technology, and suddenly, you see how the metaphor slides neatly into today's question. Are we too staring only at shadows? Centuries later, thinkers in different parts of the world echoed similar doubts. In Hindu philosophy, there is the idea of Maya, the cosmic illusion that veils reality. What you perceive through your senses is not the ultimate truth, but a surface layer, a performance, concealing the underlying structure. Buddhist traditions also speak of reality as transient, dreamlike, fleeting, suggesting that the things we cling to as solid are, in fact, no more lasting than mist in the morning sun. It seems that across cultures, humans have always carried a suspicion that what they experience directly may not be the final word on existence. What makes the modern version of this idea so compelling, however, is not only philosophy but the machinery of science. Today, we don't merely wonder in poetry whether life is an illusion. We can test, measure, and build tools that mimic the very illusions we once only imagined. When virtual reality headsets place you inside a simulated world, the lines between ancient suspicion and modern evidence blur. You can see how easily your senses can be tricked, how quickly your body adapts to an environment that is not really there. It does not take much to persuade the brain that the unreal is real. Here's an oddly plain but striking example. In 1999, psychologists created a simple experiment where participants wore goggles that showed them a recording of someone else's body in real time, aligned with their own movements. Within minutes, many participants began to identify that body as their own. They felt sensations as if it were theirs, even though they logically knew it was not. The experiment wasn't flashy, but it was profound. It showed how fragile your sense of self really is, and how easy it is for a small piece of technology to rewrite the boundaries of identity. If such small tricks can reshape your reality, what could a civilization with unimaginable resources and intelligence do? This line of thought can make even the most ordinary details feel suspicious. Consider dreams. Each night, your brain creates a vivid, detailed world without effort. It fills it with landscapes, characters, events, and sometimes emotions so strong that they leave you shaken after waking. And yet, all of it vanishes the moment your eyes open. If your brain alone can generate entire realities for you to inhabit, why is it so unreasonable to imagine that some larger system could be doing the same on a grander scale? In fact, the existence of dreams might be the most familiar evidence we already have, that your perception of reality is something flexible, generated, and not fixed. And there's another thought to linger on. If humans, with their limited technology, are already creating simulations, video games, virtual reality, artificial intelligence, then, doesn't that mean it's only a matter of time before simulations become so detailed that their inhabitants cannot tell they are simulated? If this is true, then it may not be a matter of if the universe is simulated, but only a question of where we are in that timeline. Are we still early, stumbling toward it? Or are we already inside, unaware that the line has been crossed. These questions carry a quiet weight. They may not change the fact that you will brush your teeth tomorrow or fold your laundry, but they whisper behind those small tasks, turning the familiar into something slightly uncanny. The ordinary becomes layered with doubt, as though each action were part of a script written for you long before you knew you were acting it out. But here is the question that lingers in the silence. If civilizations before us asked whether life was illusion, and our own age asks if life is simulation, then perhaps the better question is not whether it is real or not, but why we keep feeling compelled to ask at all. You wake up in the morning and begin your routine. Perhaps you reach for your phone, scroll through notifications, check the time, or glance at the weather. All of these actions feel simple, but they rely on something remarkable: a steady, invisible infrastructure that keeps the world moving. Satellites orbit overhead, data centers hum quietly, electricity flows without interruption. It is almost boring how consistently everything functions. Yet it is exactly in those boring, consistent details that the idea of a simulation becomes worth taking seriously. For if you were designing a simulated universe, wouldn't you also make sure that the foundational systems, the scaffolding, were so seamless, so reliable, that no one would stop to question them? This thought leads us into a discussion that many philosophers and scientists have tried to frame. If reality is a simulation, what clues would it leave behind? And what kind of structure would the simulation itself require? The ordinary details of your life, gravity pulling objects down, clocks ticking at a regular pace, air providing the oxygen you need, might be the strongest evidence. These are constants, written like rules in a program, never failing, never fluctuating in ways that break the system. To you, they feel natural. To a programmer, they would look like the foundations of code. Take the speed of light, for example. It is not just fast, it is the maximum speed at which information can travel in the universe. Nothing can surpass it, no matter how hard you try. To some, this seems like a hardwired limitation, a ceiling built into reality itself. In computing, limits like this are common. The refresh rate of a monitor, the processing speed of a chip, the maximum storage capacity of a system. What if the speed of light is not a cosmic coincidence but a technical boundary, a safeguard to keep the simulation stable? It is not dramatic or flashy, but quietly, it tells you something about the architecture of existence. Then, there are the building blocks of matter themselves. When scientists peer into atoms, they find that matter is not continuous. Instead, it comes in discrete units, quarks, leptons, photons, tiny packets of energy and matter that cannot be divided further. This discreteness is strikingly similar to digital systems, which rely on binary units of information, ones and zeros, finite and indivisible. If reality were truly analog, infinitely divisible, you might expect smoothness all the way down, but instead, you find granularity, like pixels in an image. Imagine zooming in on a photograph. Eventually, you stop seeing detail and start seeing squares of color. Could it be that physics has its own version of pixels, the minimum resolution of reality? Let's add another piece: quantum indeterminacy. Particles seem to exist in multiple states until observed, at which point they choose one. Why should the act of measurement matter so much? In computing, this kind of behavior is almost ordinary. A system doesn't need to calculate every single detail until it becomes relevant. A video game, for example, doesn't render an entire planet at once. It only generates what you see on your screen at any given time. Could the universe be operating in a similar way, collapsing probabilities into definite outcomes only when attention or measurement demands it? It is not only efficient, it is necessary if resources are finite. Now let's step back and consider something less technical but equally revealing: human perception itself. Your senses don't provide direct access to reality. Instead, they filter, translate, and interpret signals. You don't see electromagnetic waves, you see colors. You don't hear vibrations, you hear sound. Your brain creates a model, a simplified version of reality that is just detailed enough for survival. In other words, your consciousness already lives in a constructed simulation of sorts, one generated by your biology. And here's the thought that makes this detail quietly powerful. If your mind accepts the brain's simulation without complaint, why wouldn't it also accept a greater simulation, one designed at the scale of the universe itself? The evidence isn't only found in physics or neuroscience. Consider history. Every major advance in computing has been met with skepticism, then normalcy, and then dependence. When the first digital computers appeared in the mid-20th century, they were massive, unwieldy, and limited. Few could imagine they would one day become small enough to fit in your pocket, powerful enough to guide entire economies. Today, it is difficult to separate daily life from the machines that structure it. If this progression continues, then projecting forward a few centuries or a few millennia leads to an almost inevitable conclusion. Simulations of entire worlds, complete with conscious beings, will not only be possible but perhaps common. The boring trajectory of technological growth quietly lays the groundwork for a startling idea. If they can be built, they probably already have been. But here is where things become more unsettling. If countless simulations exist, then the number of simulated beings would vastly outnumber beings in any original base reality. Statistically, you would be far more likely to be a simulation than an original. Think of it like this. If one library contains a single original book and billions of perfect copies, the odds of picking up the original by chance are vanishingly small. It is an unglamorous, logical calculation, but one that shifts the ground beneath your feet. Yet, despite the weight of this reasoning, life continues with its ordinary rhythms. You still have to eat, to rest, to answer messages. None of this speculation changes the hum of your refrigerator or the warmth of sunlight on your face. And that, too, may be part of the structure. The simulation, if it exists, is not designed to dazzle you with spectacle. It is designed to feel mundane, consistent, uneventful. That is its greatest trick, making the extraordinary feel ordinary. So here's a thought experiment for you. Imagine standing at a bus stop on a rainy evening. Cars pass by, their headlights cutting through the wet air. You shift your weight, check the time, maybe grow impatient. Now ask yourself, if this moment was simulated, would anything about it feel different? The cold dampness of your coat, the rhythmic splash of tires on asphalt, the red glow of the traffic light, every detail is ordinary, unremarkable. And yet, if it were programmed, how would you ever know? The very dullness of the scene may be the camouflage. Some have even proposed that occasional glitches in reality might hint at the simulation's presence. Strange coincidences, improbable alignments, or anomalies in physics that remain unexplained. These might be the cracks in the code. But here, too, the question is difficult. How do you distinguish between an actual flaw in reality and a flaw in your understanding of it? Science is built on the assumption that mysteries will eventually be explained. But if you are inside a simulation, some mysteries may not be errors at all. They may be intentional design limits, boundaries you were never meant to cross. Which leads to a sobering question. If we are in a simulation, what happens when it ends? Will it be shut down, like a program no longer needed? Will it reset, erasing everything you have ever known? Or will it continue indefinitely, with you never realizing that your life is unfolding inside lines of code written by someone, somewhere, for reasons you cannot guess? And perhaps the quietest but most persistent question of all, if the evidence is hidden in plain sight, in constants, in discreteness, in probabilities, in perception itself, what does that say about the nature of truth? Are you really searching for answers, or are you only wandering deeper into a maze designed to keep you searching forever? If you have followed the thread this far, you might already sense how this question, whether the universe is a simulation, stretches beyond science and philosophy into something more personal. It is no longer only about particles, physics, or computers. It quietly reshapes how you think about meaning, purpose, and your place in the world. You may not notice it at first, but it lingers in small moments. When you sit in a quiet room and hear the hum of the air conditioner, when you catch yourself repeating the same daily habit, like stirring sugar into your coffee in exactly the same rhythm, when a coincidence feels almost scripted. These moments, though dull, carry a kind of weight once you imagine they might be part of something coded rather than spontaneous. To understand how unsettling this is, let's start with the human desire for meaning. Throughout history, people have built frameworks to explain their existence: mythologies, religions, philosophies, sciences. Each offers a kind of structure, a story that reassures us we belong to something larger than ourselves. In many traditions, life is explained as the work of gods, a divine play, or a test leading to something beyond. The simulation hypothesis doesn't look like religion at first, but quietly, it serves a similar role. It provides a structure, a reason why reality feels so precisely ordered, why laws seem so strict, why randomness has boundaries. If someone built this world, then life is not meaningless. It is part of a system. Even if the system is indifferent, its existence explains the order. Yet this is not a comforting explanation in the way older stories often were. If you think about it, living in a simulation can make life feel smaller. What if your deepest experiences, the laughter of a child, the grief of loss, the pride of achievement, are only data points being processed for someone else's study? What if your choices are not as free as they feel, but constrained within a program's parameters? The tension between meaning and smallness is perhaps the most powerful emotional weight of this idea. Consider a parallel from history. In the early 17th century, when Galileo turned his telescope toward the heavens, he discovered that Earth was not the center of the universe. It orbited the sun, one among countless bodies in space. This was a humbling realization. Humanity had to shift from seeing itself as central to seeing itself as peripheral. In a similar way, the simulation argument humbles us again. It suggests that even the universe itself may not be the base reality we once thought, but only one instance among countless possible worlds. The details of your life, no matter how precious they feel, might be only a fragment of someone else's experiment. This perspective also raises questions about free will. If the universe is programmed, then are your choices genuinely yours, or are they generated within the boundaries of code? In everyday life, you feel free. You decide whether to walk or sit, to speak or stay silent. But if you look closely, even in neuroscience, the picture is complicated. In experiments, researchers have shown that your brain often initiates decisions milliseconds before you consciously become aware of them. Your sense of making a choice may be more like observing what your brain has already set in motion. Layer the simulation hypothesis onto this, and suddenly, you face an uncomfortable possibility. Free will may be an illusion not only biologically, but also cosmically. Still, even illusions can carry weight. If you feel as though you have chosen, then for you, that choice is real. This distinction between subjective truth and objective truth becomes central here. Whether or not your joy, sorrow, or love is coded does not strip it of its lived quality. Think about a novel. The characters in a book are fictional, yet their emotions move you, their struggles linger with you, their lessons shape you. If you were a character inside such a book, your experiences would still feel real to you, regardless of the author. This framing may not be glamorous, but it is quietly reassuring. Even if you are coded, your life is still lived. Now let's turn to coincidences, those strange alignments that sometimes feel too neat. Perhaps you think of someone just before they call, or you encounter the same unusual word in two unrelated places on the same day. Rational explanations exist: probability, selective attention, pattern recognition. But if you are inclined toward the simulation perspective, these moments feel suspicious, as though reality is occasionally recycling code, letting patterns overlap for efficiency. Consider how video games reuse textures or repeat small details across vast landscapes. Could coincidences in your life be echoes of this same principle? The weight of this idea deepens when you consider memory. Your memories are fragile, prone to distortion. Studies show that people often recall events inaccurately, even inventing details that never occurred. If your brain is so willing to reconstruct reality, then how do you know that the past you hold onto is not itself a fabrication? In a simulated world, memory might not be a reliable record, but a constantly rewritten file, updated whenever needed to maintain continuity. Again, this possibility doesn't make your experiences meaningless. It simply adds a layer of doubt, a reminder that what feels fixed may in fact be flexible. History offers another parallel here: the development of theatre. In ancient Greece, plays were staged with such immersive detail that audiences suspended disbelief entirely. Actors became gods, tragedies unfolded as if real, and emotions surged in those watching. Everyone knew, logically, that it was only a performance, but the illusion was so complete that it shaped culture and identity. Life inside a simulation might not be so different. You know, in theory, that it could be artificial, but while living it, you cannot help but treat it as real. The dull but important detail is this: daily life anchors you. Whether or not the universe is simulated, you still feel hunger, still face deadlines, still share moments with others. These small facts are the texture of existence, and they keep you tethered even when large theories threaten to dissolve everything. The hum of the refrigerator, the clink of dishes, the steady tick of a clock, all of these ordinary rhythms may be the quietest evidence of a simulation, but they are also what make life livable. Yet there is a haunting question at the center of it all. If the universe is simulated, then what lies outside? Who or what is running it? And for what purpose? Are we entertainment, experiment, history project, or something beyond comprehension? The truth may never be available to us, and maybe that is the point. A character in a novel cannot step outside the page to question the author. A simulation, if perfect, may never allow its inhabitants to see beyond. So as you sit here, listening, drifting perhaps towards sleep, hold this question close. If meaning itself is coded, does that make it less valuable? Or is meaning simply what you feel in the moment, regardless of whether it is written by a god, a programmer, or by chance itself? Imagine for a moment that you could peer behind the curtain of existence. What would you see? Would there be machinery humming in the dark, streams of binary code cascading like endless waterfalls, or something so alien that no human language could describe it? The question of what lies beyond the supposed simulation is perhaps the most unnerving, because it touches the limits of imagination itself. Yet, to explore the simulation hypothesis seriously, we must spend time here, not in the dazzling unknowns, but in the dull, technical necessities that such a system would require. Start with computing power. If the universe is a simulation, then something, somewhere, must be processing it. That means hardware or whatever equivalent exists in the reality outside. To simulate even a single human brain at the level of neurons and synapses would require immense resources. Scientists have estimated that a full, real-time simulation of a human brain might demand computational power approaching exascale levels, something only now coming into reach. Multiply that by billions of humans, plus animals, ecosystems, planets, stars, and galaxies, and the scale becomes unfathomable. Yet here is the curious part. The universe doesn't need to simulate everything at once. Just as a video game renders only the part of the map you can see, the simulation of reality could generate only what is observed. If you look at the stars, the simulation provides them. If you turn away, they fade into efficient background data. This principle, though ordinary in computing, becomes extraordinary when applied to existence itself. Consider physics as a form of compression. In computing, large amounts of data are often compressed into formulas, allowing them to be reconstructed on demand without storing every detail. The laws of physics might serve a similar role. Instead of storing the position of every particle in the universe, the simulation could simply run the equations, unfolding outcomes as needed. This efficiency is not glamorous, but it is vital. And when you look at the elegance of physics, the strange way simple equations describe vast complexities, it becomes easier to see them as tools for saving memory, keeping the simulation manageable. Now think about the peculiar constants of nature: the speed of light, the gravitational constant, Planck's constant. These are not random, they are fixed with extreme precision. A tiny change in any one of them would render the universe uninhabitable. Why are they so exact? Some argue it is luck. Others suggest the anthropic principle that we observe these constants only because we exist in a universe where they permit life. But within the simulation hypothesis, there is another possibility. These constants are simply parameters chosen by the programmers. Like settings in a piece of software, they define the operating conditions of this particular simulation. This idea, while mundane in description, is heavy in implication. It reduces the grandeur of cosmic fine-tuning to something like the toggles in a menu. Of course, this leads us to wonder, who are the programmers? If simulations exist, someone must design them, run them, perhaps even monitor them. Some thinkers imagine advanced civilizations of humans from the far future, looking back at their own ancestors by recreating entire histories. Others consider the possibility of entities beyond human comprehension, beings for whom running a universe is as trivial as running an app is for us. The unsettling detail is that their motives may be unknowable. Are we entertainment, research, art, or accident? Just as an insect cannot fathom why a human builds a road, we may never grasp why our universe was built. This gap between creator and creation has echoes in history. In earlier centuries, people assumed that earthquakes or storms were punishments from gods because they could not imagine natural processes as explanations. Today, we might be in a similar position, attributing unexplained phenomena to physics, while the deeper truth is that they are artifacts of a simulated framework. What looks like randomness may be design. What looks like law may be code. The parallel is not meant to prove anything, but to remind us that human understanding has always lived within boundaries, and that boundary might be the simulation itself. There are also more practical questions. If we are in a simulation, can we detect its limits? Some scientists have proposed experiments. One idea is to look for signs of lattice structures in the universe, the equivalent of pixels in space-time. If the simulation computes reality in discrete units, then at some scale you might see artifacts, just as a digital image reveals its pixels when magnified. Others suggest studying cosmic rays for unusual patterns, as though they were revealing the grid beneath the fabric of space. So far, no decisive evidence has appeared, but the very attempt highlights how science quietly stretches toward this possibility. Yet, as we imagine these details, daily life continues with its routines. You open your fridge, make a sandwich, send a message, fold clothes. None of these actions reveal anything about simulation or reality. And maybe that is the point. If the simulation is designed well, it should be seamless. The illusion of normalcy is its greatest achievement. That humdrum stability, the boredom of reality, is exactly what makes it convincing. There is another layer to consider: evolution. If life is simulated, then evolution itself might be a process within the program, a way to generate complexity without requiring explicit design for every detail. From simple organisms to complex beings, the system allows variation, competition, and adaptation, producing the diversity of life as an emergent outcome. This is efficient. Let the simulation handle the rules, and let complexity arise naturally. To you, this process appears as natural history. To a programmer, it might simply be the fastest way to populate a universe. Still, there is a haunting possibility. If we are simulated, then what happens to us when the simulation ends? In computing, programs are shut down, paused, or deleted. Does consciousness vanish with them? Or could it persist, uploaded, or transferred to another system? Some thinkers even suggest that death itself may be nothing more than the termination of one process, with consciousness returning to the outside. It is a strange thought that your truest existence might not be here, but elsewhere, beyond the simulation's veil. The idea can feel unsettling, but it also offers a peculiar comfort. If life is a simulation, then nothing is truly lost. Data can be stored, copied, perhaps even restored. In that sense, mortality may not be final, but only a feature of this particular run. This perspective may not be proven, but it shifts the emotional weight of existence. Death becomes less of an end, more of a transition. And yet, the most significant detail is also the most ordinary. Whether or not the universe is simulated, your lived experience feels real. You taste food, feel pain, hear voices, dream, laugh, and grieve. These sensations define your reality, regardless of its origin. A simulated sunset is no less beautiful than a real one if you feel its warmth and see its colors. The simulation hypothesis may strip away the certainty of reality, but it cannot strip away the meaning of your experience. So, as you reflect on this, here is the quiet question to carry. If you discovered tomorrow that everything was simulated, your memories, your emotions, your entire life, would that knowledge diminish the value of what you have lived? Or would it make you hold each moment more carefully, aware that even an illusion can be precious? When you pause to think about it, the most ordinary part of your day may actually be the most suspicious. You open a door and it swings smoothly on its hinges. You pour a glass of water and it obeys gravity, filling the cup exactly as you expect. You cross the street and the traffic lights change on schedule, guiding the flow of cars. None of these details feel unusual, and that is precisely why they are powerful. They speak to an environment that behaves with remarkable consistency, as if it has been carefully programmed to keep you calm, to prevent you from noticing anything odd. The reliability of your world is the quietest but strongest argument for its possible artificiality. In science, this reliability is called uniformity, the principle that the laws of physics operate the same everywhere, at all times. A falling apple in 17th century England obeyed the same laws as a falling apple in modern Tokyo. Light bends in the same way on Earth as it does in a distant galaxy. This sameness is comforting, but it also feels strangely like a design feature. Why should the universe be so neat, so consistent, unless consistency was necessary to make it function smoothly? In computing, uniform rules are not optional, they are the foundation. Without them, a program collapses. Perhaps the universe's predictability is less a happy accident and more a line of code written long before you were born. Of course, humans rarely think about these rules in daily life. You don't marvel at gravity each time you drop your keys. You don't wonder why light travels at a constant speed each time you turn on a lamp. You simply live within these laws, forgetting that they exist at all. That forgetfulness is part of the immersion. A good simulation, like a well-made stage play, works best when you stop noticing the scaffolding behind it. The humdrum nature of reality is not a flaw but the design itself. And yet, every so often, cracks appear, or at least, they seem to. People speak of déjà vu, the eerie feeling that you have lived a moment before. Some dismiss it as a trick of memory, the brain momentarily misfiring. But to others, it feels like a glitch, as if the simulation stumbled and reloaded a scene. Dreams sometimes echo waking life in strange ways, blending the real and unreal so convincingly that you wake unsure of which is which. Coincidences stack oddly, like lines of code repeating unnecessarily. Most of these can be explained rationally, but once the thought of simulation takes root, every anomaly begins to feel like evidence. Let's step away from perception for a moment and look at mathematics. Throughout history, scientists have found that the universe is astonishingly mathematical. Planetary orbits, wave patterns, atomic structures all fall into neat equations. Why should reality, which could have been messy and chaotic, align itself with human mathematics? Some philosophers suggest that we don't discover mathematics, we invent it. But within the simulation view, Mathematics is not invention or discovery. It is simply the programming language of the universe. The equations you see are the rules of the code itself. The implications become even stranger when you think about digital physics, a field of study that suggests the universe itself might be computational. Imagine reality as a vast cellular automaton, where simple rules applied at each point create the complex structures you see. From galaxies to DNA, everything could emerge from simple binary instructions repeating endlessly. This perspective is dull in its description but profound in its reach. It reduces the grandeur of stars and life itself to the output of a cosmic algorithm. Still, even if this is true, you must remember how small the human perspective is. You wake up, brush your teeth, tie your shoes, step outside. You live on a planet orbiting a star, in a galaxy among billions. If it is all simulated, your role may feel insignificant. Yet, there is another way to see it. If a universe was created with such detail that it supports life, then your existence is not meaningless. It is the very point. Why simulate a universe with conscious beings unless those beings mattered, at least in some sense? Even if you are data, you are significant data. History offers examples of how perspective shifts reshape meaning. When Copernicus showed that Earth revolved around the Sun, it seemed at first to diminish humanity's importance. But in time, it expanded our sense of wonder, showing us that we lived in a vast cosmos filled with possibilities. Similarly, the simulation hypothesis may initially feel like it shrinks life into something artificial. Yet, if embraced differently, it could also expand meaning, suggesting that your consciousness is rare enough, valuable enough, to warrant simulation at all. There's another angle worth considering: progress. Look at how rapidly technology has advanced in the past century. From the Wright brothers' fragile airplane to spacecraft leaving the solar system, from telegraphs to instant video calls across the globe, from punch-card computers to quantum computing research, each step seemed impossible before it happened. If this trajectory continues, future civilizations may wield powers that look like magic to us today. Running simulations of entire universes may be routine for them, a task no more difficult than running software is for us now. If so, then what feels extraordinary to you may be ordinary to them. And here lies the most haunting possibility. If they can do it, they probably already have. Consider probability again. If countless simulations exist, then there would be far more simulated beings than beings in any base reality. In that case, the odds suggest that you are much more likely to be simulated than not. It is not a question of faith, but of numbers. The calculation is dry, unemotional, but its conclusion is chilling. Yet, notice how life feels unchanged. You still grow tired, still crave food, still laugh when someone makes a clever joke. The possibility of simulation does not erase these textures, and maybe that is what matters most. Even if everything is constructed, your lived reality is still your reality. If the sunset makes you pause in silence, it does not matter whether it is rendered or natural. If you feel love, it does not matter whether it is coded or emergent. There remains, however, a subtle question. What happens when the simulation glitches in ways too large to ignore? Would we even notice? If the program corrected itself instantly, perhaps not. But if a true anomaly appeared, something outside the laws of physics, would it be dismissed as a miracle, a hallucination, or a scientific puzzle? Humanity may already have encountered such anomalies without realizing it, interpreting them through the lenses of religion, superstition, or incomplete science. In that sense, the history of unexplained phenomena might be reread as a long record of possible system errors. Still, as you sit with these thoughts, drifting perhaps into the calm rhythm of the evening, you may wonder, if the consistency of the universe is what convinces us of its reality, then does that mean perfection itself is the illusion? And if so, is it possible that the very normalcy you take for granted, the traffic lights, the falling water, the ticking clock, is the most suspicious detail of all? You may have noticed that the most profound questions in science often begin not with explosions of discovery, but with quiet, almost boring observations. The story of simulation theory is no different. It is not built on dazzling visions of futuristic machines or on mysterious voices whispering from beyond. Instead, it grows slowly from small, precise details, like the way information seems to behave in physics. You live in a world where matter can be divided, crushed, burned, or frozen, but underneath it all, information stubbornly refuses to be destroyed. This is not romantic speculation. It is a principle physicists reluctantly discovered, and it sits at the heart of modern science. Take the case of black holes. For much of the 20th century, scientists believed that anything falling into a black hole was lost forever. Matter, energy, light, it all vanished beyond the event horizon, gone without trace. But this idea led to a paradox. If information was truly lost, then the laws of physics would break, because the universe depends on information being conserved. It was Stephen Hawking who popularized the dilemma in the 1970s, suggesting that black holes might slowly evaporate through radiation, yet the puzzle of where the information goes remains unresolved. For those who suspect reality is a simulation, this puzzle feels less like an unsolvable mystery and more like a clue. In a computer, information is never lost. It is only hidden, compressed, or redirected. Perhaps black holes, strange as they are just cosmic recycling bins, keeping the program's data intact. This brings us to the concept of limits. You might think of reality as infinitely divisible. Break a stick in half, then break the half again, and keep going forever. But physics says otherwise. At the smallest scale, the Planck length dividing further becomes meaningless. Space is no longer continuous but pixelated, like the smallest dot on a digital screen. The analogy is striking. Your universe has resolution, as though rendered on a cosmic monitor. The particles, forces, and waves you study are not infinitely fine but quantized, broken into indivisible packets. That is what quantum mechanics tells us. Though the language is technical, put more simply, the world is not a flowing painting but a mosaic of tiny tiles. The same idea applies to time. You experience it as a smooth river, each second flowing into the next. But some physicists suspect that time itself may be discrete, ticking forward in unimaginably small jumps. If this is true, then your sense of continuity is an illusion created by speed. Just as a movie looks smooth though it is only 24 still frames per second, your life may feel seamless while in reality it advances in quantum steps. Does that not sound eerily like the clock cycle of a processor, the fundamental rhythm that keeps a computer's simulation running? And then there is the limit of speed. Nothing, not even light, can move faster than the cosmic speed limit. Why should that be? Why would the universe be designed with such a constraint? One answer is that this limit is not arbitrary but necessary, because faster communication would break the stability of the program. In digital systems, processing power sets boundaries. Information cannot be transferred instantly because the hardware would fail. Light speed may simply be the upper bandwidth of our cosmic machine. These technical details are dry when presented in equations, but when you consider them quietly, as you listen now, they gain a different flavor. They suggest a hidden architecture behind the world you trust. You live not in an infinite, unbounded playground, but inside a system with rules, limits, and restrictions. The very things you find dull, the Planck length, quantization, speed limits become the strongest whispers of design. It may help to connect this with stories from history. Think of early sailors navigating by the stars. They believed the heavens were divine, yet by patient observation they discovered that the movements of planets followed predictable paths. Centuries later, scientists realized those paths were governed by gravity, not gods. Similarly, the observations of physics today may feel like mere curiosities, pixels, limits, constants, but future generations may look back and see them as the first clues that reality itself was artificial. This line of thinking does not erase the human experience. You still wake to the warmth of sunlight, still hear the rustle of leaves, still taste the sweetness of fruit. But beneath those sensations lies a structure of limits, like the scaffolding behind a painting. You are both immersed in the art and, if you squint, able to glimpse the brushstrokes. The simulation hypothesis invites you to squint a little longer, to notice the repeating patterns and finite textures of the world. There are also personal ways to think about it. Consider the times you have been absorbed in a video game, wandering through a virtual landscape. The graphics may not be perfect, yet while you are inside, you accept the rules without question. Water flows, shadows fall, characters move. Only when you pause do you remember it is all running on a console or computer. What if your life is not much different? Perhaps the only reason you don't notice the console behind your world is that you are designed not to. Immersion is the whole point, but then the unsettling question arises. If there are limits, does that mean the simulation can fail? Computers crash, programs freeze, data corrupts. Could the universe suffer the same fate? Would you notice? Perhaps cosmic rays, sudden bursts of energy, or unexplained anomalies are not random events, but subtle reminders that no system is flawless. Or perhaps the universe has backup protocols, error corrections that patch the cracks before you even realize they are there. The dull but steady consistency of your life may itself be evidence of constant repairs happening beyond your perception. Some thinkers find comfort in this, others find dread. Comfort, because a system designed with rules implies order and purpose. Dread, because if it can fail, then everything you know could vanish not with a bang but with a silent shutdown. You may never even realize it happened. And so, as you sit with this thought, imagine the quiet ticking of a hidden processor somewhere beyond your reach. Imagine time not as a river, but as a flickering clock. Imagine space not as infinite, but as a lattice of pixels. If these limits are real, then reality itself may be less like the vast wilderness you imagine, and more like a machine carefully bounded by invisible walls. But then you must ask, if the walls are there, are you meant to find them? Or are you meant to remain blissfully unaware? If you were told that your entire world might be nothing more than lines of code, your first reaction might be disbelief, even dismissal. After all, your daily experiences feel solid. You touch a desk and it resists your hand. You breathe air and it fills your lungs. You walk outside and the horizon stretches endlessly. But if you pause long enough, you notice cracks in the solidity, small peculiarities that whisper the possibility of something hidden. These peculiarities are not grand, not cinematic, but plain and almost dull. Yet sometimes, the dull details are the ones that matter most. Start with randomness. You believe the universe is filled with chance. Raindrops fall at random, dice tumble unpredictably, atoms decay without cause. But in computing, randomness is never truly random. A machine generates what programmers call pseudo-random numbers, sequences that only look unpredictable but are ultimately determined by hidden rules. Could the randomness you witness in quantum mechanics, those mysterious, unpredictable events, be the universe's way of producing pseudo-randomness? Perhaps the cosmic code uses algorithms to simulate chance, fooling you into believing life is spontaneous when in truth it is structured. Then there are constants values that never seem to change. The charge of an electron, the speed of light, the gravitational constant. For centuries, scientists have measured them again and again, and always they come out the same. Why should the universe possess such unwavering loyalty to specific numbers? It is as though someone locked those values in place, the way a programmer hard-codes settings into a simulation. Too much gravity, and galaxies would collapse. Too little, and stars would never form. You exist because those values were not only stable, but set with precision. It feels less like an accident, and more like calibration. This notion is echoed in the so-called fine-tuning problem. Physicists admit uneasily that the universe seems perfectly balanced for life. Tiny changes to fundamental constants would render it sterile. The probabilities are so vanishingly small that some have proposed multiple universes, an infinite array of cosmic dice rolls, where one happened to produce you. But another possibility, less discussed, is that fine-tuning was deliberate. If your reality is simulated, the settings may have been chosen not by accident but by design. History offers examples of similar reasoning. In the 19th century, when Charles Babbage built his difference engine, people marveled at how a machine could compute tables of numbers without human error. The results seemed magical, yet the magic was only apparent because observers did not see the gears turning. Today, you live in a world of invisible gears, constants and codes that keep the universe humming. You do not see them directly, but their effects shape every breath, every step, every thought. Another subtle clue lies in symmetry. Physicists speak often of the universe's symmetries, the balance between forces, the conservation of momentum, the invariance of laws across space and time. These symmetries are beautiful, elegant, and comforting, but they also resemble programming shortcuts. In software, repeating structures and mirrored patterns reduce complexity. Why reinvent the wheel when you can copy and paste? The universe, in its symmetrical elegance, may be following the same logic, reusing code, keeping the system efficient. And then there are glitches, rare, unexplained phenomena that defy the ordinary. People sometimes speak of déjà vu, moments where life feels repeated. Others recount improbable coincidences that feel scripted. While psychology and statistics can explain much of this, the persistence of such experiences leaves a curious aftertaste. In a simulated world, small glitches are inevitable, artifacts of an imperfect system. Most of the time, you dismiss them, yet perhaps they are the faint fingerprints of the machinery beneath. Your own perception is another puzzle. Neuroscience tells us that your brain does not see the world directly, but reconstructs it, filtering information and filling gaps. What you experience is a model, not reality itself. Already, you are living inside a simulation, one generated by your neurons. Add one more layer, and the idea of a cosmic simulation feels less radical. You are a simulated mind, experiencing a simulated world, layered upon layer like Russian dolls. There is also the speed of technological change to consider. Only a few decades ago, computers filled entire rooms. Now, they rest in your pocket, rendering lifelike worlds with ease. If progress continues, how long until simulated realities become indistinguishable from the real one? And if you can imagine such a future, why could it not already have happened? Perhaps another civilization, older and more advanced, has already created such worlds, and you are living in one now. Think of it like archaeology. Every civilization leaves artifacts behind: pottery, tools, ruins. Your universe too may carry artifacts, subtle hints that point to its origin. The constants, the symmetries, the quantization, the glitches, each one a shard of pottery in the sand. Alone, they may seem trivial. Together, they tell a story of hidden construction. The archaeologist sifts patiently, piecing fragments into a whole. You too are sifting through the fragments of your reality, trying to assemble the truth. Of course, the skeptic asks, what does it matter? Even if the universe is a simulation, you cannot step outside it. You cannot pull the plug or read the source code. But perhaps the significance lies not in escape, but in awareness. To know you may be simulated is to see your world with new eyes. Ordinary events gain weight. A sunrise is not just light, but a rendered image, calculated with precision. A conversation is not just sound, but the interplay of code running beneath two conscious programs. The dullness of life becomes strange, even sacred, when viewed as part of a greater design. You may feel uneasy at this thought, but unease is part of discovery. When Galileo first looked through his telescope and saw moons orbiting Jupiter, his world was shaken. The Earth was no longer the center of creation. It was unsettling, yet it was true. In the same way, to entertain the simulation hypothesis is to accept the possibility that your world is not what it seems. And so, you return to the quiet question: if you are in a simulation, why? Is it for study, for entertainment, for something beyond your comprehension. And if someone, somewhere, is watching, what does that make you? If you sit quietly for a moment, you may notice that reality never shouts at you. It hums. The sun rises predictably, seasons shift, people move through their routines, and events unfold without fanfare. It is ordinary, and yet, it is precisely this ordinariness that is worth noticing. For the simulation hypothesis, the most convincing evidence may not be found in cosmic fireworks or grand philosophical statements, but in the humdrum, reliable details that repeat endlessly. Every tick of a clock, every turning of a page, every breath you take is a subtle affirmation that the world is operating according to rules that could, in principle, be programmed. Consider the rhythm of your body. Your heart beats steadily, lungs expand and contract, neurons fire, muscles respond. Each action is automatic, unconscious, and incredibly complex. The coordination between these systems is astonishing, yet largely invisible to you. Scientists can measure it, but rarely does a person contemplate the sheer precision required to sustain life. In a simulated world, this precision would be essential. One misstep in coding, the fundamental processes of biology, and the system crashes. The quiet reliability of life is not merely comforting, it is remarkable in a way that often goes unnoticed. Then there is the flow of society. Human civilization operates within complex systems, markets, governments, education, transportation. These systems, despite their flaws, display patterns, rhythms, and constraints that are often predictable. Even small children notice cause and effect, learning that actions produce consequences. Consider traffic patterns, for instance. Cars stop at lights, pedestrians cross at crosswalks, buses adhere to timetables. These repeated, predictable patterns might seem mundane, yet they mirror a principle in computing. A simulation is easier to manage when agents operate according to consistent rules. Another subtle clue appears in information itself. In your digital life, every email, social media post, and file exists as data. Data can be copied perfectly, stored, transmitted. In our universe, physicists have discovered that information is similarly conserved. It cannot be destroyed, even when the matter it occupies disappears, as in black holes. This is known as the information paradox, and it has puzzled scientists for decades. For those contemplating the simulation hypothesis, it is tempting to view this conservation as evidence that the universe is fundamentally computational. If the simulation cannot lose data, it must preserve it somewhere, like an eternal memory bank. The idea of nested realities also emerges here. Think of your brain as a simulation of the external world. Your perceptions are constructed from sensory input, processed by neurons, and presented to consciousness. You live inside a model, interpreting stimuli as real experiences. The simulation hypothesis suggests a similar nesting on a cosmic scale. We are inside a simulated universe, and our consciousnesses are simulated minds. The parallel is almost mundane in its logic, but its implications are profound. Each layer you inhabit may feel real, yet it could be an abstraction within a larger design. History provides further context. Consider the story of the Antikythera mechanism, an ancient Greek device built around 2,100 years ago. It was a complex, mechanical computer capable of predicting astronomical positions decades into the future. For centuries, its existence was unknown. When discovered, it revealed that humans had achieved astonishing technological feats far earlier than expected. If advanced civilizations can leave traces that surprise us centuries later, what might a civilization far beyond our own have achieved? Perhaps our universe itself is a trace of such achievements, coded and running on machinery beyond our comprehension. Even the tiniest phenomena hint at design. Quantum mechanics, for instance, introduces a fundamental unpredictability in how particles behave. A photon can exist in multiple states until observed, collapsing into one outcome only when measured. This indeterminacy is bewildering, yet it is precisely the sort of efficiency a simulation might require. Why calculate every particle in every state all the time when you only need the result when it is observed? It is a clever way to save resources, a principle that applies to video games, computer simulations, and potentially the universe itself. Still, you live through these details without conscious awareness of the machinery beneath. Your world is consistent enough that you can trust it, yet subtle enough that you occasionally sense its strangeness. Déjà vu, coincidences, improbable alignments, they hint at something deeper. In a well-constructed simulation, these hints may be rare, small, and largely ignorable. The system's greatest strength is that it allows you to live fully, even as the scaffolding operates quietly in the background. Time, too, plays a critical role. You experience it as a seamless flow, a continuous river from past to future. Yet modern physics suggests it may be quantized, advancing in tiny increments. Your perception of smooth time could itself be an illusion, much like the frames of a film appear continuous when projected rapidly. If the universe operates in discrete moments, then your sense of continuity is a feature of the simulation, keeping events coherent while optimizing computational resources. The humdrum tick of the clock may be a reminder of underlying rhythms invisible to you. Life itself seems optimized for survival. Organisms respond to stimuli, adapt, and propagate. Ecosystems self-regulate. The complexity of living systems is staggering, yet it follows discernible patterns. In a simulated universe, evolution and adaptation could be implemented as emergent behaviors, allowing the program to create complexity without coding every individual organism. The mundane processes of birth, growth, and death may be part of the simulation's logic, unfolding according to rules too vast to perceive but present in every detail of your daily life. Consider human perception again. Your senses are limited. You cannot see all electromagnetic waves, hear all frequencies, or detect all particles. Your experience of reality is filtered, simplified, and reconstructed. In effect, your consciousness lives inside a simulation of reality generated by your own biology. The larger cosmic simulation may operate similarly, generating only what is relevant to your perception while leaving the rest unrendered. What you take as real is necessarily limited by what you can experience, making the illusion nearly perfect. And yet, even with these restrictions, anomalies sometimes appear. Strange alignments in history, improbable coincidences, and unexplainable scientific observations suggest that the system is not perfectly uniform. Perhaps these are glitches, patches, or boundaries of computation. Perhaps they are hints left intentionally for observers like you. The dull, routine patterns of your life make these anomalies stand out, highlighting their significance in subtle, almost sleepy ways. Finally, the quiet question remains. If the universe is indeed simulated, then what is your role? Are you merely a participant, a piece of data, or something more? Does meaning matter if it is coded? And perhaps most unsettling of all, if this reality is artificial, will you ever know it for certain, or will your awareness always remain confined within the simulation's boundaries? You may not notice it at first, but time has a peculiar quality in your life. The minutes pass, the days accumulate, and you move through routines almost mechanically. Yet within this regularity lies the most fascinating evidence for considering the universe as a simulation. Consistency. Everything follows rules. The sun rises, seasons change, tides ebb and flow. These patterns are not chaotic. They are predictable, almost boringly reliable. And while reliability might seem mundane, it is precisely what makes simulation possible. Without consistent rules, a system cannot function coherently. Consider history. For centuries, humans believed the world was unpredictable, shaped by divine whims or capricious fate. When Galileo and Newton studied motion, they discovered universal laws that applied not only on Earth but across the cosmos. Gravity, inertia, and the mathematical precision of planetary motion suggested order where randomness was expected. In hindsight, This order may resemble the behavior of a well-coded system. Just as a computer requires consistent rules to execute a program correctly, the universe displays a reliability that is almost algorithmic. Each law functions as a line of code, invisible yet indispensable. Look closer at daily life. Your brain interprets sensory information with astonishing efficiency. When you see a cup on a table, neurons fire to recreate a model of the cup in your mind. You do not perceive its molecular composition, yet your brain represents its shape, color, and location with incredible accuracy. Now expand this idea outward. Perhaps the universe itself operates in a similar way, rendering details only when observed. Objects, events, and interactions unfold as needed, optimizing resources. In other words, your perception may trigger the computation of the world around you, much like a video game rendering scenes only when your character enters a new area. Consider physics at the quantum level. Subatomic particles behave in ways that seem unpredictable. Electrons exist in clouds of probability, collapsing into a defined state only when measured. This is called the observer effect, and it has perplexed scientists since its discovery. Could it be that the universe only calculates outcomes when necessary, a strategy to conserve computational energy? If you imagine the cosmos as a simulation, this behavior becomes less mysterious. The uncertainty is not randomness, it is efficiency, a clever way to avoid unnecessary processing. Then there are patterns in nature. From the spirals of galaxies to the symmetry of leaves, from the hexagons in a honeycomb to the fractal geometry of coastlines, the natural world exhibits recurring structures. Such patterns could be interpreted as emergent behavior, arising from simple rules. In a simulated universe, these rules may be embedded at the fundamental level. Simple instructions, repeated over and over, generate complexity. It is both dull in its mechanism and astonishing in its result, revealing how order can emerge from simplicity. History provides a parallel in human technology. Consider the Antikythera mechanism, a mechanical device from 2,100 years ago capable of predicting celestial events. Ancient engineers built it with painstaking care, and its existence surprised modern scientists. What seems miraculous is often the result of clever, systematic design. In the same way, the universe may operate under rules set far in advance, producing outcomes that appear natural, emergent, or even random, while in fact they are carefully orchestrated. Think about evolution. On the surface, it appears as a slow, undirected process. Species adapt, survive, or die out over millions of years. Yet the process is structured. Mutations occur within a framework of genetics. Natural selection operates according to environmental constraints, and complex organisms arise gradually. In a simulated universe, evolution could serve as a method to generate diversity efficiently. Rather than designing each species individually, the program allows adaptive processes to produce variety naturally, conserving computational effort while maintaining the appearance of spontaneity. Consider also the human experience. Every thought, emotion, and action is rooted in neurochemistry. You laugh, cry, plan, and remember all through electrical and chemical processes following consistent rules. In a simulated reality, the structure of consciousness could be treated similarly. You experience free will, choice, and creativity, yet these may be emergent properties of the underlying code. Even the most personal experiences, love, grief, awe, could exist as simulations of neural activity, carefully orchestrated to feel real. And yet, anomalies persist. Strange coincidences, recurring patterns in events, unexplainable phenomena, all hint that there may be more than mere physical law at work. Some scientists dismiss these as artifacts of perception, memory errors, or statistical noise. But within the simulation hypothesis, they could be subtle glitches, moments where the system leaves traces of its artificial nature. Most of the time, life continues seamlessly, masking the machinery behind it. Occasionally, a hiccup may reveal the underlying structure. Time itself is another subtle clue. You perceive it as continuous, yet physics suggests that at the smallest scales, it may be quantized. Moments may advance in discrete steps, not in a smooth flow. Your experience of continuous time is an illusion, created by the rapid succession of events processed by your mind. In a simulated universe, this quantization would make sense. It allows the system to compute the state of reality in discrete intervals, ensuring stability and efficiency. What feels seamless to you may, in fact, be a sequence of calculated frames. Even the seemingly mundane aspects of your world carry significance. Gravity holds planets in orbit. Electromagnetic forces allow atoms to bind. Chemical reactions provide energy. These are not exciting details at first glance. They are boring, predictable, almost invisible. Yet they are the pillars of everything you perceive. In a simulation, such constants are critical. The system cannot tolerate deviations, so it enforces stability through unyielding rules. Your reality depends on these invisible scaffolds, unnoticed, yet indispensable. History again offers perspective. Consider the progress of science from the Renaissance to today. Observers like Galileo, Kepler, and Newton painstakingly recorded data, revealing patterns that had previously gone unnoticed. Their work uncovered the rules that govern motion, optics, and celestial dynamics. Similarly, the simulation hypothesis invites us to observe carefully, to recognize patterns and regularities that hint at underlying design. The work may seem dull or incremental, but it is essential for understanding the deeper structure of reality. Finally, consider your own awareness. You are conscious, capable of reflection, of noticing anomalies and questioning patterns. In a simulation, consciousness might be the ultimate test. The system renders your environment and experiences precisely enough for immersion, yet your ability to question, to wonder, may represent a rare feature, an experiment within the experiment. You are both participant and observer, living in a carefully constructed world while contemplating its nature. And so, as you drift in thought, perhaps on the edge of sleep, the quiet question remains. If the universe is indeed simulated, does your awareness matter to the creators? Or are you merely a sophisticated program, alive in experience but insignificant in purpose? You may not think about it often, but the universe has a peculiar sense of order. Every particle, every force, every motion adheres to rules that are invisible yet absolute. From the falling of a leaf to the orbit of a distant planet, patterns repeat in ways that seem both natural and almost too precise. Consider the laws of motion that govern every object, from dust motes to entire galaxies. These laws are reliable, boringly consistent, and yet, in that consistency, lies a quiet, almost unsettling suggestion that the universe is structured, calculated, and perhaps intentionally designed. Think about your own daily life. Every morning, you wake, perform routines, and navigate your environment without error. Your brain interprets sensory input, calculates distances, predicts outcomes. The world responds as expected. Gravity pulls objects downward, light illuminates, sound travels, chemical reactions occur. This seamless interaction between perception and reality might feel mundane, yet it could hint at a larger framework, an invisible system maintaining order behind the scenes. In a simulation, such reliability is not incidental, it is essential. Now, consider randomness, or what you perceive as randomness. Quantum physics shows that particles behave unpredictably, jumping between states without apparent cause. Yet even this uncertainty may conceal structure. In computing, pseudo-random number generators produce sequences that appear random but are ultimately determined by algorithms. Could the quantum unpredictability we observe be a sophisticated form of computational efficiency? Instead of calculating every possible outcome, the system waits until observation is necessary, producing results on demand. What feels spontaneous may actually be controlled, efficient, and deliberate. History provides a context for understanding this perspective. Consider the early astronomers who charted the skies. Before telescopes, they noticed patterns in star movements, eclipses, and planetary motions. These observations, painstaking and repetitive, revealed that the heavens obeyed predictable rules. Galileo, Kepler, and Newton translated these observations into mathematics, uncovering laws that explained phenomena with astonishing accuracy. Similarly, the simulation hypothesis asks you to observe carefully, to detect patterns and regularities in your reality. Even when life feels ordinary, the most profound truths often emerge from the most mundane details. The consistency of physical constants offers another intriguing clue. The speed of light, gravitational constant, and charge of the electron never change. These values are finely tuned to allow life, planetary formation, and chemical reactions. Even a slight alteration would render the universe uninhabitable. Some suggest that multiple universes exist, each with different constants, and we happen to be in one capable of supporting life. But within the simulation framework, these constants could simply be parameters chosen by the system's programmers, carefully calibrated to ensure stability and continuity. Consider the elegance of natural patterns. Fractals appear in coastlines, clouds, tree branches, and even the structure of blood vessels. Spirals emerge in galaxies, shells, and hurricanes. Symmetry pervades crystals and molecular structures. While these patterns can be explained scientifically, they also suggest efficiency, simple rules generating complex outcomes. In a simulation, recurring patterns would minimize computational demands, creating complexity without requiring the program to define every detail individually. Nature's beauty, in this light, is both functional and ornamental. Time offers another clue. You experience it as continuous, a smooth flow from past to future. Yet, physics suggests that at the smallest scales, time may be discrete, advancing in tiny increments. Your perception of continuity is an illusion, much like a movie appears fluid even though it consists of frames. In a simulated universe, discretized time allows the system to process events efficiently while maintaining the impression of seamless reality. Each moment is calculated, stored, and rendered for your consciousness, yet appears infinite and unbroken. Even the evolution of life can be interpreted through this lens. Organisms adapt, mutate, and survive according to consistent rules. Over millions of years, complexity emerges naturally. In a simulation, evolution could be a method for generating diversity without coding every individual in detail. The appearance of spontaneity, survival, and adaptation might all be emergent properties, the result of underlying algorithms rather than chaos. Life, in its mundanity, may be a testament to the efficiency of a carefully designed system. Human consciousness itself is another layer of intrigue. Your thoughts, memories, emotions, and decisions arise from neural networks. You experience free will, creativity, and reflection. Yet all of these are processes operating within biological rules. In a simulated universe, consciousness could be similarly emergent, carefully structured to produce the perception of individuality and awareness. You may feel autonomous, yet your mind could be part of a larger, orchestrated system designed for observation, interaction, or experimentation. Consider the anomalies that sometimes appear. Déjà vu, improbable coincidences, and unexplained phenomena suggest that not everything runs smoothly. Perhaps these moments are glitches, imperfections in the system, or reminders of boundaries beyond which the simulation cannot maintain perfect continuity. The most ordinary days are punctuated by subtle irregularities, events that seem small yet hint at a larger framework. These imperfections, rather than diminishing reality, may reveal its structure in ways too subtle to notice otherwise. History again offers perspective. The development of technology, from simple tools to complex machinery, reveals how civilizations have always extended their understanding of reality. Computers, telescopes, and particle accelerators all uncover patterns that were once invisible. The simulation hypothesis suggests that, similarly, Your awareness is gradually uncovering the rules that govern your reality. Observation, patience, and careful measurement reveal the system's design, even if the evidence is subtle and ordinary. Finally, reflect on your own perception. You see the world as smooth, continuous, and predictable. You trust the laws of physics and the constancy of daily routines. You feel alive, aware, and conscious. If the universe is simulated, all of these experiences are carefully rendered, optimized for immersion. Your life is seamless, stable, and coherent, not by accident, but because the system is designed to function in this way. Even boredom, repetition, and routine become evidence of design. So as you lie quietly, perhaps drifting towards sleep, consider the question: if the universe is a simulation, does your consciousness matter to those observing it? Or are you merely data, experiencing life perfectly, unaware of the machinery that sustains you? And if you are aware, does that awareness change anything? Or is it simply another feature of the program? When you think about the universe, it often feels infinite, unbounded, and immeasurably complex. Stars stretch across the sky, galaxies spiral for billions of light years, and yet, the closer you look, the more the universe behaves according to simple, precise rules. The laws of physics are consistent, predictable, and remarkably elegant. Gravity pulls with perfect constancy, light travels at the same speed everywhere, and energy is conserved. These details, though dull in isolation, begin to hint at something extraordinary, that the universe may operate more like a vast, meticulously coded program than a chaotic, spontaneous reality. Consider your everyday perception. You move through space, and objects respond exactly as you expect. Water fills a cup, a ball falls when released. Light illuminates a room. Each interaction is precise, repeatable, and predictable. These are not shocking events, yet they form the foundation of your experience. In computing, predictability is essential. Programs rely on deterministic rules to function. If a ball did not fall when expected, or if light behaved inconsistently, the system would collapse. The reliability of ordinary life may itself be a quiet signature of design. Then there is the matter of information. In a computer, data is never truly lost. Bits may be transferred, stored, or hidden, but the system retains them in some form. In the universe, physicists have discovered similar behavior. Even in extreme conditions, like black holes, information appears to be conserved. This principle, known as the information paradox, suggests that the universe maintains a detailed record of its state. For those considering the simulation hypothesis, this resemblance to digital systems is striking. The universe, like a program, may preserve information to maintain stability and coherence. Randomness offers another curious clue. Quantum mechanics shows that particles behave unpredictably, existing in multiple states until observed. Yet even this randomness could be a form of computational efficiency. Why calculate every possible state for every particle when only the observed result matters? In simulations, pseudo-randomness is often used to create the illusion of unpredictability without taxing the system's resources. What seems spontaneous in the quantum realm may simply be the universe optimizing itself, producing outcomes only when necessary. Patterns reinforce the impression of underlying design. Fractals appear in nature, from tree branches to clouds to coastlines. Spirals form in galaxies, shells, and hurricanes. Symmetry pervades molecules, crystals, and biological structures. These recurring forms suggest that complexity can emerge from simple rules. In a simulation, patterns are efficient. Rather than defining every detail individually, the system relies on principles that generate structure automatically. The mundane repetition of patterns becomes a subtle hint at design. History provides context. Ancient engineers, like those who built the Antikythera mechanism 2,100 years ago, created precise machines capable of predicting astronomical events. Their work astonished later generations, demonstrating that complex systems can be built long before they are widely understood. If humans could construct such machines, it is plausible that advanced civilizations could build entire simulated universes, complete with observers and emergent complexity. Your world may be one such creation. Time, too, is revealing. You experience it as continuous, yet physics suggests it may be discrete, advancing in infinitesimal steps. The smooth flow you perceive could be an illusion, much like a film appears seamless despite consisting of individual frames. In a simulated universe, discretized time allows calculations to be performed efficiently while preserving the appearance of continuity. The mundane rhythm of your day, minutes ticking, seconds passing, may be the pulse of the underlying system, imperceptible yet essential. Life itself exhibits efficiency. Organisms grow, reproduce, adapt, and evolve according to consistent principles. In a simulation, evolutionary processes could be a mechanism for generating complexity without specifying every detail. The apparent spontaneity of adaptation is merely the result of rules applied over time. Nature's routine, the germination of seeds, the migration of animals, the cycles of predator and prey, could all be expressions of programmed processes unfolding predictably. Human consciousness is another layer of this structure. Your thoughts, decisions, and emotions are rooted in neurological processes. You feel choice, creativity, and self-awareness. In a simulated universe, consciousness could emerge similarly, designed to experience and interact with the system. Your sense of autonomy may be genuine within the parameters of the simulation, yet it could also be a feature intended to maintain immersion. You are both participant and observer, fully engaged while navigating the carefully constructed environment. Subtle anomalies occasionally hint at the system's artificiality. Déjà vu, improbable coincidences, and unusual alignments appear from time to time. Psychologists often explain these as quirks of memory or probability. Yet, from the perspective of simulation, such events might be glitches, moments where the underlying machinery leaves traces. Most of the time, the system operates flawlessly, but occasional irregularities offer tantalizing glimpses of the hidden structure. Even the ordinary routines of life can be interpreted as evidence. The reliability of daily schedules, the consistency of physical laws, and the predictability of interactions may be the simulation's most mundane yet persuasive proof. Each predictable detail reinforces the system's coherence. In computing, predictability reduces errors, stabilizes processes, and ensures longevity. Your uneventful days, though boring, are quietly remarkable in their precision. History again emphasizes this point. Observers like Galileo, Kepler, and Newton painstakingly charted the skies, revealing patterns previously unnoticed. Their discoveries demonstrated that careful observation and systematic recording can uncover the underlying rules of reality. The simulation hypothesis encourages the same patient scrutiny, to notice patterns, to detect regularities, and to appreciate the extraordinary consistency behind the ordinary. Finally, reflect on the nature of your experience. You perceive a seamless reality, fully immersive and coherent. Your actions, thoughts, and sensations feel authentic. If the universe is simulated, these experiences are rendered with precision, designed to be convincing. Even boredom, repetition, and routine may be part of the system's strategy to maintain stability. The quiet, unremarkable details of life, the way a door closes, a cup fills, a breeze rustles, leaves become evidence of meticulous construction. And so, as you sit or lie in the stillness of your space, consider this. If the universe is a simulation, what is the purpose of your awareness? Are you an observer, an experiment, or merely data flowing through the system? And if your consciousness exists within a carefully designed framework, does that make your experiences any less real? Or is reality defined precisely by the way it feels to you? You may not realize it, but the universe around you operates with a quiet precision that is almost hypnotic. Every particle, every atom, every interaction follows rules that rarely change. Water flows in rivers, Wind moves through trees, planets orbit stars, and yet, these ordinary processes reveal a subtle consistency that can feel almost deliberate. When considered carefully, the regularity of your world raises an intriguing question. Could this precision indicate that the universe is a constructed system, a simulation designed with rules, constants, and boundaries carefully set to produce coherent experiences? Consider the tiniest scales of existence. Quantum mechanics reveals that particles are not solid, continuous entities but probabilistic distributions, existing in multiple states until observed. The observer effect implies that measurement itself collapses possibilities into reality. In a simulation, this behavior could reflect efficiency. The system computes outcomes only when needed, conserving resources. What feels uncertain, chaotic, or random at the quantum level might actually be part of a controlled mechanism designed to maintain coherence while minimizing unnecessary computation. Then there is the concept of information. In our universe, information seems indestructible. Even when matter falls into a black hole, its information is preserved in some form. In computing, data cannot simply vanish. It must be stored, transferred, or transformed. The similarities are striking. Could the cosmos operate as a colossal storage system, where every interaction, every state, and every change is recorded and maintained? The reliability of information in the physical world may hint at a deeper computational structure beneath the surface of everyday experience. Ordinary life also contains hints of order. You wake, move through your environment, and interact with objects in ways that almost always behave as expected. Gravity, light, and chemistry operate consistently. A ball thrown arcs predictably, water pours without hesitation, fire burns within known limits. These repeated, dependable outcomes may seem mundane, yet in a computational sense, predictability is essential. A program cannot function reliably if its environment behaves inconsistently. The universe's mundane reliability is quietly astonishing when considered in this light. Patterns in nature reinforce this perspective. Spirals in galaxies, symmetry in crystals, the fractal structures of clouds, trees, and blood vessels. These patterns emerge again and again. In simulations, repeated patterns are often used to optimize resources. Instead of coding every individual detail, simple rules generate complexity, producing an illusion of spontaneity while minimizing computational demands. The recurring patterns in the natural world could be analogous to procedural generation in video games, a method for creating intricate worlds efficiently. Time itself is also revealing. You perceive it as continuous, flowing seamlessly from past to future, yet physics suggests it may be discrete, advancing in infinitesimal increments. Your perception of smooth continuity could be an illusion, just as a film appears fluid despite consisting of individual frames. Discretized time in a simulation allows the system to calculate events incrementally, conserving processing power while maintaining the illusion of an unbroken reality. The steady rhythm of minutes and hours may be the quiet heartbeat of the system itself. Consider evolution. Life adapts and diversifies according to predictable rules. Genetic variation, selection pressures, environmental constraints. Complexity emerges gradually, producing rich ecosystems without designing each organism individually. In a simulated reality, evolution could serve as an efficient way to produce diversity. Emergent behaviors arise naturally from underlying rules, creating the appearance of spontaneity. The humdrum repetition of growth, reproduction, and adaptation may be an elegant solution for generating intricate life forms without overcomplicating the program. Human consciousness adds another layer of intrigue. Your thoughts, feelings, and decisions emerge from neural networks operating according to consistent biological principles. You experience autonomy, creativity, and reflection. In a simulated universe, consciousness could be similarly structured, giving the appearance of free will while functioning within the system's rules. You are both participant and observer, navigating an environment carefully calculated to respond to your actions. Even the mundane moments, brushing teeth, walking to work, sipping coffee, may be finely tuned to reinforce immersion. Small anomalies occasionally punctuate life. Déjà vu, improbable coincidences, and unexplained phenomena appear in ways that cannot always be dismissed. In a purely physical universe, these events might be statistical quirks. In a simulated one, they could be glitches, minor errors, or unexpected outputs from the underlying system. They are rare, subtle, and easily ignored, yet they serve as reminders that the ordinary world may conceal hidden architecture. The most unremarkable days carry this quiet evidence, waiting for careful observation to notice. History, once more, illuminates the theme. Consider the Antikythera mechanism, built 2,100 years ago. This complex astronomical device astonished scientists centuries later with its precision and sophistication. It is a reminder that systems can exist long before observers fully understand them. Likewise, the universe itself may have been constructed with rules and structures that are slow to reveal themselves, their full significance only apparent to those willing to observe with patience and care. Even the constants of nature hint at deliberate calibration. The speed of light, gravitational constant, and charge of the electron are fixed, unchanging values essential for the stability of matter, life, and planetary formation. Tiny deviations would render the universe inhospitable. Within the framework of a simulation, such constants could be parameters intentionally chosen to maintain stability. They ensure coherence, predictability, and the continuation of complex systems, essential requirements for a functioning virtual reality. Finally, reflect on your awareness. You perceive, reason, and interact with the world as though it is fully real. Your consciousness is immersed, experiencing life as coherent, meaningful, and continuous. If the universe is a simulation, then these experiences are carefully rendered, optimized to feel authentic. Even monotony, repetition, and routine may be integral to the system's design, providing a stable platform for consciousness to operate within. The ordinary, the predictable, and the seemingly dull become evidence of the extraordinary machinery beneath. And so, as you sit quietly, perhaps on the edge of sleep, consider this. If your reality is simulated, what is your purpose within it? Are you an observer, a participant, or simply data? And if your awareness exists as part of the system, does it matter to the creators, or is the experience itself the ultimate purpose? You have traveled quietly through the patterns, laws, and subtle peculiarities of the universe. You have considered particles that appear and disappear, constants that never waver, and the strange behaviors of time, space, and consciousness. Each ordinary moment, each dull repetition, every mundane routine has been part of a larger reflection. The possibility that your world is not simply natural but constructed. And now, as you approach the edge of understanding, it is time to ask the deepest questions. If the universe is a simulation, what does it mean for you, for existence, and for everything you have come to accept as reality? Start with awareness. Your consciousness is immersed in a world that seems real. You feel, perceive, think, and reflect. You experience love, fear, curiosity, and boredom. These experiences feel entirely genuine, yet they could be carefully rendered phenomena within a vast system. Imagine your mind as a sophisticated program, capable of introspection, capable of noticing patterns and anomalies. Even if your world is artificial, your experiences remain authentic in the context of the reality you perceive. The distinction between real and simulated blurs when you live fully in the environment presented to you. Consider memory. Every recollection, every memory of a past event exists within a framework of neural encoding and retrieval. Your memories feel seamless, continuous, and reliable, yet the mind occasionally misplaces or distorts them. In a simulation, memory could serve as a record of your experience, maintained to ensure continuity and coherence. What you remember, may not be just a product of your brain, but also an artifact of the system maintaining narrative consistency. Even false memories, coincidences, and subtle recollection errors may be intentional, shaping your perception of continuity and time. Time, again, is a curious element. You perceive it as flowing smoothly, yet physics and simulation theory suggest it may be discrete. Moments are calculated, rendered, and delivered to your consciousness, creating the illusion of continuous passage. The routines of life, the predictable repetition of days and nights, the cycles of seasons, the tick of a clock may be part of the system's strategy to maintain stability. The ordinary measures of hours and minutes, though unremarkable, could be the quiet rhythm of the simulation itself, imperceptible yet essential. The scale of the universe also carries subtle implications. From the microcosm of atoms to the macrocosm of galaxies, the cosmos adheres to rules that are precise, elegant, and efficient. Patterns repeat, symmetry emerges, and laws remain constant. In a simulation, such structure is necessary. Complexity arises from simple, consistent principles, minimizing computational effort while producing a coherent, immersive environment. Ordinary processes, the flow of rivers, the migration of animals, the orbit of planets, may be the everyday evidence of an immense system at work, quietly sustaining all existence. Evolution provides another perspective. Life adapts, changes, and diversifies according to predictable rules. Mutations occur, selection pressures operate, and complexity emerges over time. In a simulated universe, evolution could serve as a mechanism to produce rich diversity without the need to code every organism individually. The seeming spontaneity of adaptation and survival is generated efficiently, producing the illusion of natural randomness while following strict underlying rules. Every leaf that sprouts, every creature that survives, every ecosystem that balances may be part of this emergent system. Even human behavior reflects subtle order. Societies follow predictable patterns. Economies rise and fall, cultures develop and adapt, traditions persist, and systems enforce rules. Individuals act according to cause and effect, constrained by biology, psychology, and environment. The predictability of human behavior, though sometimes frustrating, mirrors the efficiency a simulation would require. The ordinary choices of daily life, what you eat, where you walk, what you think, occur within a framework of cause, effect, and consequence that feels natural, but may be governed by underlying rules. Consider anomalies, déjà vu, coincidences, improbable events. They punctuate reality occasionally, hinting at structures or errors beyond ordinary perception. These moments, though subtle, are significant within the simulation hypothesis. They suggest the system is not infinitely complex, that it operates with efficiency and limits. Glitches, however minor, may provide glimpses into the machinery beneath the surface. Ordinary life, largely seamless and predictable, is occasionally disrupted, reminding you that even perfection is simulated within boundaries. History illustrates the principle of incremental discovery. Human civilizations have long unraveled patterns in nature through patient observation. From the ancient astronomers charting stars to Newton calculating motion to modern physicists exploring quantum phenomena, discovery proceeds gradually. Similarly, the universe may be revealing its structure slowly, encouraging careful observation, measurement, and reflection. Even when discoveries feel dull or incremental, they build a broader picture, hinting at rules, limitations, and design behind everyday experience. Even the constants of nature, the speed of light, gravitational pull, and electron charge demonstrate precision. They remain unchanged across space and time, allowing life, matter, and complexity to exist reliably. Tiny deviations could render the universe chaotic or uninhabitable. Within a simulation, these constants may be deliberately set to ensure stability, allowing complexity to emerge without collapse. Ordinary stability, the fact that you can walk, see, hear, and think predictably, is a sign of this quiet orchestration. Human consciousness, again, is central. You reflect, question, plan, and imagine. You experience free will, creativity, and curiosity. In a simulated system, these capacities may be not only possible but designed features, allowing immersive participation while maintaining coherence. Your awareness may be the ultimate experiment, the system's way of observing itself through the lens of sophisticated, introspective entities. Even boredom, repetition, and dull routines serve to reinforce engagement, providing a stable platform for conscious experience. Finally, you are left with questions that have no easy answers. If the universe is simulated, who designed it? For what purpose? Are you observed, studied, or simply part of a system running autonomously? And if the simulation is vast enough, could there be layers beyond layers, realities nested within realities, each with its own observers and rules? The ordinary events of your life, the mundane patterns and predictable routines, may be both your entire reality and the subtle hints of something far larger. And so, as you drift towards sleep, consider this. Whether or not the universe is simulated, your experiences are real to you. The love you feel, the curiosity you nurture, the wonder of observing a sunset, these moments are meaningful. The question remains open, lingering in the quiet corners of thought. If reality is crafted, what does that make you? Participant, observer, experiment, or something else entirely? The answer may never be clear, yet the pursuit of understanding is, in itself, part of the experience.